order, but they're the exact same characteristics. There is one description that can be used two ways. But don't worry, on the answer key I have it marked down that I would take either or. I don't remember if it's a function or a derivative, but there is one description that is the exact same, just written in a different order. You might be able to tell which one is better because of the order it's written in, but it doesn't matter. There is one description, just in case you're like, what? That's the exact same as another. Just be careful, only one. And then derivative description, I don't remember. Is it strictly decreasing or something? Did anybody find that one? It's little lowercase m. I just don't know what the actual words are.
The derivative is positive for x is less than 0 and negative for x is greater than 0.
Okay, the derivative is positive, aka f prime is above, aka f is increasing for x less than 0. The derivative is negative, aka below on the function graph of the derivative, where f is decreasing. Anyway, so what are you supposed to do? Find all 16. By when? Friday. Using what? Each other. How could you split up the work? Any ideas? One person can do all the function graphs with descriptions, what they think. One person can do all the derivative graphs with all the descriptions. One person can be a resource and then check all of it at the end. Or all of you guys could check it like in the 5 minutes before class, putting the burden on the person who didn't get to see them yet. Because most of your groups have 3, so one person can be. So you could theoretically, I think the descriptions are probably the easiest matchings. Not that they're easy, but they're easier sometimes than putting the derivatives with the functions. So some of you might want to be like, okay, hold on, who do we want to give the hardest job to in a way that will be beneficial for the entire group? And then give the other 2 people, if you only have a group of 3, maybe the description job. And then the other person can be a resource, like for you to reach out to, be like, hold on, let me take a picture. Like these 4 cards, I'm not sure, is this one, that one, this one, etc. So one person can be the resource, and then you guys can come together and then give that one person the job of functions with derivatives if you guys agree, and then everybody checks it. Or you could work on it all together, like during a lunch or after school or in 0 period. So you guys, I'm going to give you about 3 minutes, 4 minutes to powwow and plan out how you're going to get it done by Friday at the end of the day. Ready, set, go. You're giving out jobs. You're thinking about who's going to do what. Maybe you're sketching graphs so you don't have to worry about it. All the way until Friday at the end of the day, yeah. If you get all the sketches down, maybe the person with the derivatives can already start thinking about matching. And then another person functions and derivatives. Okay, you're going to want to split up the jobs right now because you're not going to necessarily have time to totally do it in the 5 minutes beginning of class. You lost it. I have one. I need to make some copies. No. I'll be able to have them for you tomorrow, Kyrie. For right now, just think about the matches. You don't need to necessarily have it written down yet. Does that make sense? Yeah, and I'll have other ones for tomorrow.
Oh, yeah. Lady. Most likely. Yeah. This one's blank. I don't know about this one. So it might just be the 0.
What has a derivative of 0? What does a constant function look like?
Get the constant out. Right here.
Light bulbs. All right, 1 more minute before you have to put this whole thing away. So strategize. What are you going to split up? Who's going to take what home? Who's going to be on call? Are you guys able to make 0 period tomorrow? Do you have another time? Do you think you can cram it into the 5 minutes before class for the next 3 days? One more time, just in case you have a small group. You both have the sketches down to the functions. Whoever takes the derivatives home, even though they don't have the function descriptions, they can already start thinking about, a parabola should have a linear derivative. A linear derivative should have a constant. Sorry, a linear function should have a constant derivative. A constant function should have a 0, which doesn't answer all of them, but answers some. Yeah. You guys are supposed to take care of those cards until Friday when you turn in your assignment. Thanks, Victor. Maximums and minimums that are smooth turns in an f of x should be intercepts, x-intercepts in the derivative. That one's helpful. Increasing, decreasing of f shows above or below of f prime. All right, put it away. So figure out what you're going to do. Figure out who's going to take what. I'm going to walk around with extra rubber bands just in case you guys have split up your functions and derivatives. I don't want lost cards. This took forever to make. I probably should have paid someone to do it professionally, but I was a young teacher. Thought I could do it all myself. If you guys need to split up functions and derivatives, here's an extra rubber band so you don't lose my cards. If you need to split up, here's an extra rubber band. Let me give you guys a couple rubber bands because the bag sometimes dies. Another one? Yeah. Okay, any more rubber bands are needed? Oh, you're good? Are you keeping them all together? Look at you. All right. All right, any more rubber bands necessary? We good? Okay. So what on earth are we doing for the last 10 minutes, 9 minutes, 8 minutes of class? What else is on the board? Forever quiz, check. Graph match, check. What else? Whoo, what did I not give you over break? Okay. What did I not give you over break? A full-length practice exam. Why? Well, let's look at it and see why. First of all, looking at this one, let me go ahead and make it full screen. Zoop, zoop, zoop. You're not taking it. You're just getting exposed to it. Let's put it that way. Okay. This is a full-length international exam that was taken like in the different AP classes that are not in the continental U.S. Oh, my goodness. Are there a lot of directions that are going to be given at the beginning of the AP exam by Mrs. Pratt or Mrs. Kendrick? Probably. How many questions total? Wait a minute. There's a section 1 and a section 2. Section 1 and a section 2. What are they? Well, we'll talk about them when we get there. Have you heard a lot of AP directions if you've taken an AP test before? Probably. But let's not. Ooh, look, it's an answer sheet. That's fun. There are 120 multiple choice spaces? Yes, but that's not how many questions that you have. Okay, here we go. The first section, multiple choice section. Wow, we're used to multiple choice questions, right? To some degree. All right. At a glance. Total multiple choice section will take 1 hour and 45 minutes, split into 2 pieces, a part A and a part B. Now, to make the timing a little less awkward, 55 and 50 minutes, a lot of testing coordinators hated. So now they've bumped it a little bit to make this 30 questions in 1 hour, and then 15 questions in 45 minutes. They like the hour 45 split up that way. It makes sense. But what's the difference? 30 questions with no calculator, and 15 questions with calculator. Wonder what the difference is. What do we got? Do you guys know that inverse trig and arc trig is the same thing? Good. Do you know that the domain will be all real numbers unless it's not? Okay, good. So, section A, the 30 questions. This one has 28, but it's been updated since then. Should you know how to do this? Yes. Yeah! What rule are you going to use? Oh my goodness, maybe you'll pass the AP. Okay, so number 2. How about the word increasing? Take a derivative, look for critical numbers, make a sign chart, and look for where it's positive. It meaning the derivative. How about number 3? What is that? Pause. Before coming into this class, how many of you guys knew what, before even doing the summer packet, how many of you guys knew what dy dx was? Okay, 1 or 2. Before coming into this class, before doing the summer packet, 1 or 2 had seen that before and had any idea what it was. So guess what? You know how we had to learn what a derivative was? And you guys know a lot more than you would have if I had asked you to write an essay on the derivative the first day of class. What could you write now? There's a curve, and there are these tangent lines, and they stand for instantaneous rates. And by the way, there's a definition that has to do with a limit. And by the way, that has to do with secant lines, going closer and closer to the tangent line, getting infinitesimally small intervals. Anyway, you might not go into that. And there are all these rules. Oh my goodness, let me tell you about the rules and how I memorize the rules and how I can use the rules. And oh my goodness, we can use derivatives in order to approximate stuff. And we can use derivatives to optimize things. And we can apply them to all sorts of, okay, not saying I'm going to make you write an essay, but long story short, guess what we have to do second semester? Learn the integral. The same way we learn the derivatives. So, do you know how to do number 3?
No.
If I gave you a full-length practice exam over break, would you have had to skip number 3? Yes. Is that good for you guys to see that you need to skip number 3? Yes, you know what you know and what you don't know, but we have a lot more to learn. But pause. Yeah, you guys can go. Does that mean that we can only do numbers 1 and 2? No, because look at number 4. Oh my goodness, that's so easy. Take the derivative and plug in. Unless you don't know the derivative of ln of x, you haven't studied your forever cards. Okay, next one. Do you guys see how it's just a limit with a graph? Do the 2 drivers meet at the diner? Is it a problem if the diner is burned down? All things that we're going to keep reviewing. How about number 6? Can we go from, it's motion. You guys should know this, but wait.
There's more.
Going from, have we gone from velocity backwards to position? Backwards. Don't we go from position to velocity, first derivative, from velocity to acceleration, another derivative? Have we ever gone backwards? Maybe it's an integral. Okay, number 7. Y prime, take a derivative, chain rule. What? Number 8. It's a table that maybe we don't know how to do yet. Okay, number 9. Piecewise function, something to do with continuous limits and plugging in and finding. We've seen that. Okay, long story short. Non-calculus, right? You recognize some of this. You recognize some of this. Okay, now pause. Those are non-calculator multiple choice. Some you would know how to do and some you wouldn't. Some you should know how to. Isn't that a definition of the derivative? But ln, but what's the derivative of ln? 1 over x, and who is x? Dun, 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 easy. If you see it. Right? Okay. But wait a minute, that's just the first section. Isn't there a whole other section of multiple choice called section B? Section B only has 15 questions. This one, end of A. You're allowed to get out your graphing calculator. How much did we use our graphing calculator last semester? So what's different? Wait a minute. F prime, positive and increasing with letters. Is there anything to put in your calculator? No. Does every calculator question need a calculator? No, there aren't even numbers or functions. You'd have to think about what positive and increasing. Wait, the derivative positive. The derivative positive means f is increasing, and the derivative increasing means f double prime is positive, aka f is concave up. So where is this concave up and going up? Only here. Right? Only here. Okay, anyway, not everything needs a calculator, but, ooh. Well, IVT, not so sure that needs a calculator either. This one, ooh. Okay, are we going to have to review some things with calculators and why on earth we're supposed to be finding decimals? Yes, but is this also a nasty function that maybe we couldn't find the derivative and set equal to 0? Oh, not set equal to 0. At this point. We have to play a little bit with our graph and intersections and then plugging into the derivative, but using our calculator, it'll go faster, and we wouldn't know the decimal by hand. No decimal, doesn't need a calculator. No decimal, doesn't need a calculator. Ooh, big numbers, probably could use a calculator. Decimals need a calculator. Do you guys see how some are going to be calculator intensive and some are not? Anyway, pause. I'm going to let you go. But that's the calculator part. What comes after multiple choice? Hey, there's a light pole. What comes after multiple choice, calculator and non-calculator?
Well, free response.
Are those going to be long answers with multiple parts? Are we going to have to work on that this semester? Yeah. But do you guys see how the very first FRQ already has an integral? All right, before we can go too crazy into the AP, we need to go into integration and say, who is that guy? But by the end of the year, you'll know. Bye, guys. See you later.